Good afternoon, students. This is Statistics 1401. Today is July the 19th. So let me go over a couple of important things, guys. I have decided that today is the last day I'm going to record a lecture. Okay, so tomorrow is your study break. Tomorrow is Thursday. You can study, you can do your homework, and then from the next week, the exam will become available. I'm going over this again. The exam will become available on Monday, July the 24th, and it will be available till July 27th, midnight. And you want to take it in that window. If you miss it, I won't be able to give you an extension because the grades are due really soon, like on Friday. So it's not possible. So I'm giving you an extra day tomorrow to do your homework, to wrap up your homework, to study for the exam. Your final will be very similar to exam three. Make sure you fix all your exam three problems, and I will add a few more because we have done probably two sections. We're going to do 4.2 today, and 4.2 is also an easy section, and that's about the exam. And we are going to do 4.2. What did I put here? Grade calculation. This is how I'm going to calculate your grade. Please read this carefully. If you followed my directions, my average and your average will be exactly the same. Okay. So I will replace your lowest exam score with your final, but I'm not going to go to the Pearson site and manually do it. I'll leave it as it is. But when I download your grades in my book on my computer, I will do it. So please don't email me saying you didn't replace my lowest exam score. I will do it. And based on the formula that's in the course outline and that's on the left-hand side of the screen under announcement grade calculation, I have given you the formula. I will use this formula. If you and I use the same formula, we're going to get the same result. Okay. Now let's get into the next section, which is 4.2. It's a very straightforward section, guys. So let me give you a little overview. Okay. So let's say I have a bunch of data, okay? And we know, I know it's here, it's from your book, but I'm going to draw it if you don't mind, okay? So, okay. So let's say I have a lot of data points. The x-axis is the number of hours studied, okay? I'm going to label it hours studied, hours studied. HRS is hours studies and studied. What am I talking about? Number of hours you studied before your exam for a class. I'm talking about all students, and this is their grade. Okay. Now, we do expect that if you study more, hopefully properly, not just wasting time, if you study more, your grade will be higher. So I expect this. I expect the graph to be like this. There's a point here. This person studied very low and they got a low grade. Okay. And let's have a lot of data points. You can have like 30 students. I'm not going to make 30 dots. Okay. So to me, this is a positive correlation. I know I didn't put the coordinates. If I did, and if you use this to calculate the Pearson R that we did in 4.1, you're going to get something very close to 1. Okay. If it's close to 1, then it's called a linear relationship. Linear relationship means I should be able to draw a straight line. That's a good approximation of those points. The question is, how do we decide what line to draw? I can't just randomly pick 2 points, right? That's not going to be correct. You're going to pick 2 points. I'm going to pick another set of 2 points. It's not going to be right. So in this chapter, they discuss an official formal way of doing it. And the equation that we will come up with is based on all the line that you're going to draw, okay? All the points that you have. I'm going back to the example in your book. All these distances, when you square them, that'll be minimum, okay? So it's a lot going on. The thing is that they're going to give us a formula and we'll try to learn the formula. So they're going to give you the line. What line does a good job? When your Pearson R is close to one or negative one, what line will help you predict other points? So if somebody says, I studied 18 hours, can you predict the person's grade? That you can do with the equation of a straight line. Now, in college algebra, you probably learned equation of a straight line is given by, this is one form, y is equal to mx plus bc, doesn't matter. M is the slope, okay? Slope of a line is, if this is a line, this is the slope, how steep the line is. Okay, it's rise over run. I'm not going to give you a long lecture on that. Okay, M is the slope and B is the y-intercept. What's the y-intercept? If this is your x-axis, y-axis, and this red line is your line, let's turn it into red. Y-intercept is the point where the line crosses the y-axis, namely here. Okay, again, I'm going to write here M, sorry, M is the slope, M is the slope, rise over run, and B is the y-intercept. Okay, so if I can find M and B, I can find the line. And we're going to learn how we can find M and B. Okay, that's the basis, that's the background of what's coming up. Now, the good news is it's based on all the things we have learned to find. Okay, so so the Pearson R that we learned to calculate last class times sy, standard deviation of the y variables, divided by sx, it will give you the slope. Okay. Okay, the y-intercept is the mean of the y variables minus b1, this slope, times x bar. Okay, so if you know, we have learned how to find sx, sy, x bar, y bar, and r. If you know these 5 items, you can find the slope using the top formula, and you can find the y-intercept using this formula. Once you have those two, you have your line, you can do whatever you want with it. Most of the questions I have assigned, basically they'll ask you to find this equation of your line. So let's look at an example. Your book has a very nice example. I'll just use that example from your book. And I'm going to check if the math is right. So what they're doing, they have a data from table 2. You can look it up in 4.1. And in 4.1, we found, you will see that they have R was this 0.946, X bar was 4, SX was 2.449, and SY was 5.61. Now, you're going to use, to find B1, you're going to take R1. So let's do it. Let's do it on our calculator just to make sure we are doing it correctly. All right, so to find B1, the slope of your line, you're going to take negative 0.946 multiplied by SY, which is 5.612486. 2486 divided by SX is going to be 2.44949. And we're getting what they got, negative 2.1675. Okay, so we have the slope. Now keep the slope handy. We're going to use the slope to find the y-intercept. So right here, let's find the y-intercept. The y-intercept is, as the slope, right? Negative 2.1676. The y-intercept is 18. Let's see how they found it. Of course, we know y-intercept is y bar minus b1 times x bar. Okay, the b1 is this. b1 is the slope. I'm going to put it here. And I am going to multiply it by to find B naught or the y-intercept. I'm going to multiply it by x bar, which was 4. And then I'm going to add y bar, which is 10. And I get 1 point. Okay. 10. Oh, it's minus. My bad. I get 18.67. So we got the same thing. So this equation is the least squares regression line. Again, we use the equation once we know it has a strong linear relationship. If R turns out to be close to +1 or close to -1, we can find the equation of a line that best describes the data. Once we have the equation of the line, we can use this equation to find the relationship between the two variables. Okay, so it's a fairly straightforward section. I didn't give you a whole lot of homework problems because my exams are cumulative. So some of you are a little huffing and puffing. I can hear it when you email me. So this is all the lesson I have. I'm not gonna have a lesson tomorrow, official, but if you need help with something, if you can't do a problem, feel free to ask me. I will be happy to record a video. Other than that, go home, do all the homework problems and study 4.2. Try to go to MATLAB and do the problems from 4.2. Good luck and do well on your exam. Take care. Bye-bye.